Hello and welcome to the Weekly Space Hangout for Wednesday, April 24th, 2019. I'm Fraser Kane, publisher of Universe Today. This week we're going to be talking about a Crew Dragon just exploded. NASA Insight finds here's its first Marsquake. The future star systems that will be visited by Voyager and Pioneer. 2014 meteor came from another solar system, and oh, that's part of it. Never mind. We'll be all right. Joining me this week on my screen, we've got Dr. Morgan Rainberg. Morgan.
Hey, Fraser. Happy podcast day.
Yeah, that's right. Kimberly's not here, so we'll have to do this. We've also got Dr. Pamela Gay. You can't hear you. You're muted.
Hello, Fraser and Morgan. And everyone else.
Is this your first podcast, Pamela?
Yeah, have you ever used this?
Watch that mute button.
There's a mute button down at the bottom left-hand corner. You can use that to mute and unmute yourself. You might be familiar with this. All right, before I give my co-host any more of a rough time, I want to give a big shout-out to our good friends at the Weekly Space Hangout crew. These really are the partners of the show. They are the co-creators, co-producers, executive producers. They organize the guests like the amazing guests that we have today. They continue the conversation during the summer hiatus. And if you want, you can join. You can join the chat that's going on down below here. Great community. Go to wshcrew.space and they will hook you up and get you connected, and you can join the chat. All right, let's get on with our special guest this week. And we've got two guests who both are muted, so they've been, I'm sure, practicing their unmute keys. Nathaniel Putzig and Gareth Morgan from the Planetary Science Institute. Hey, guys.
Hey, how's it going?
All right. Whoever says hello first gets to show up on my screen. All right, so that's Gareth. Where are you located, Gareth?
I'm in Washington, D.C.
All right, and then we've got Than. Where are you located?
Hi, Fraser. I'm in Lakewood, Colorado.
All right. And so the question I always like to ask people, who are you and what do you do? Than, I'll let you go first because you're on my screen.
Well, I'm a planetary scientist, and I study Mars mostly from orbit using radar and thermal data. I'm presently hunting for ice as a resource for future human missions.
And Gareth, anything to add?
Yeah, sure. I'm also a planetary scientist who specializes in using radar. So I'm involved both studying Mars and using ice, well, looking for ice, which we'll talk about in a minute, and also studying the moon as well.
All right, so I think the instrument that everybody is going to be most familiar with is your work with the Mars Reconnaissance orbiter. Can you tell me about the instrument that you guys are using, Gareth?
Yeah, sure. So we're specifically using the radar sounder, the shallow radar sounder, or SHARAD, as it's known as. And the idea of this is basically what it does is it produces essentially an X-ray of the subsurface. So as it goes over the surface of the planet, it's recording signals not only bounced off the planet, it's a radar, but also signals are bounced off from the subsurface as well. And from that, we can work out shallow structure. We can also work out or get some constraints and composition.
Uh-oh.
He froze up.
Rock.
Yeah, Washington is offline.
Oh, did I? I'm sorry. Can you hear me now?
Yeah.
All right, great. Yeah, so we use the shallow radar, which is SHARAD, as it's known as, which is a sounding radar. And the principal, the objective of this type of radar is to produce almost like an X-ray of the subsurface. So as it flies over, it sends a signal to the surface, like any radar does. But not only does it record signals bounced off the surface, it also records signals bounced off the subsurface as well. And from that, we get an idea of the structure of, well, in ice up to about several kilometers, in rock up to a couple of, say, maybe 100 meters or so. And we can also use that to try and work out the composition of the subsurface, basically how much ice, how much rock's in there.
Then, so you actually, we were chatting a little bit beforehand, and you were telling me about sort of what kinds of structures, features, how deep you can go. What can you see down there?
Sure. So you may be familiar with the polar caps on the Earth. that have all that layering within them, layers that accumulate over the course of many thousands or even millions of years. And Mars is no different in that it has a very layered structure of its polar caps. And the radar that Gareth was describing there, those signals bounce off of those layers individually all the way down to about 3 kilometers depth. So we can see the whole structure of that layering throughout the polar cap. And this tells us a lot about how it may have formed over time. In particular, we try to relate the layering in the polar cap to the climate history of Mars over the last several million years.
And how much bigger does the polar cap on Mars extend beyond? I mean, we can see it in our telescopes. We can see those polar ice caps. But if you're able to see several kilometers below the surface, is it like the tip of an iceberg?
No, we actually, in many areas, we see the base of the ice or a strong reflection at the base of the ice where it sits on top of the regular crustal rocks. So we've actually been able to determine the full extent of the polar cap with this radar and with the other radar on the European orbiter, so-called Marsis radar.
Okay, so Gareth, your work has been in looking at some of the historical, how this relates to some of the historical features of the polar ice caps on Mars. What can you tell about how Mars has been changing over time?
Quite a lot of things, actually. Just in the same way as on the Earth, you look at layering in our polar caps to try and work out climate changes. We can do a similar approach on Mars, so we can compare the SHARAD radar signal to high-resolution images and work out different units. And if we work out those units are formed in different climatic periods, we get an idea of how things have changed through time. Also, it's not just water ice that's contained in some of the poles. If you look at the southern polar cap, we've also found from SHARAD that there's huge amounts of CO2 ice. And that's important because the atmosphere of Mars is very thin. It's dominated by CO2. And so if all of that ice was to become, a gaseous form, you could almost increase the atmosphere by a large amount. And so, there's a lot of important feedbacks. Now, we don't fully understand them. It's given us a real good insight into how the climate has changed from Martian history over the last, several million years.
And speaking of insight, we're going to be reporting on this later on, that InSight has seen its first Marsquake. Is there what kind of connection between the kinds of things that InSight is going to be looking for and the kinds of research that you guys are doing?
Actually, it's quite interesting. So a lot of work I do is, in addition to ice, is also studying the structure of volcanic deposits on Mars. And close to where InSight landed, it's on the edge of a region called Lysa and Planitia. That's a really good hunting ground from a SHARAD point of view. There's a lot of subsurface reflectors, and we're able to really get a good model of how that volcanic province is sort of built up, kind of the same way as geologists going out to the Columbia River basalts up in Washington State and looking at the various units and seeing how they build. And so, the hope is this area is a region that's had volcanic activity, every so many million years over the last 500 million years. And so there's hope there might still be a thermal anomaly or some sort of activity there. So,
Oh, we lost him again.
Still volcanic region.
Oh, we lost you again. So, Than, I had one question for you. Now, I think our viewers are familiar with the increased pressure on NASA to start sending humans to the moon and then onto Mars. And of course, water ice is going to be critical to being able to live off the land, as it were. So how will the research that you guys are doing be able to help plot out a more permanent, I guess, the first explorers and then a more permanent existence on Mars?
Yeah, that's a great question. One of the projects that Gareth and I are working on right now is specifically aimed at doing that. In particular, we're using both the radar data and some imagery data and thermal measurements to try to figure out exactly where there is buried ice in these lower latitudes, well off the poles, down nearer to the equator. And so this buried ice is potentially a great resource for supporting a human mission, not only in terms of producing water for drinking, but also the water can be used to manufacture rocket fuel, methane essentially, used together with the atmosphere. So the work that we're doing is helping map out exactly where that ice is, how deep it might be, and how concentrated it might be in the subsurface. This will inform how we go about extracting that ice and using it once we land people and equipment there.
If you had to make a snap judgment now, if you had to recommend a good place to land that has the kinds of resources that maybe future Mars explorers would need to build their rocket fuel and have some drinking water, what are some places that you think are good on the surface of Mars?
So down in the mid-latitude, say 35 to 40 degrees or so, we're finding a lot of features that look for all the world like glaciers. And in fact, the radar is pretty well shown that these are relatively pure water ice with a kind of a thin veneer of maybe a few meters at most of debris sitting on top. So these look like really promising features that we should certainly be considering landing near or even on top of, if we can find a smooth enough area to make that happen.
Yeah.
One difficulty is their surfaces tend to be kind of rough, so that could be a little dicey for landing a large spacecraft.
So there's like good spots for harvesting water, but bad places to land, and vice versa.
Yeah, that's sometimes the case. There are certainly areas, though, where these glaciers sort of come to a toe, and then there's a flat area nearby. So by studying these in greater detail, we may be able to find a kind of an optimal landing site that's just off of the glacier, and then you can drive a short distance to get to the ice and begin extracting it.
Yeah, I sort of think of a similar analogy like on the moon, they're thinking that the best place to extract water will be at these permanently shadowed polar areas.
Mm-hmm.
But you wouldn't want to live in there. You'd want to have some sunlight. So you'd need to sort of extract your resources, but then still stay out in the sunlight and go back and forth as you're trying to, you've got the place where you're gathering your water, but then the place where you're living.
Well, so actually, it's not a bad arrangement there in the polar regions, because right adjacent to the permanently shadow craters are permanently lit areas. So you can find sort of a sweet spot where you can land and collect, solar energy while you're also going into the darkness nearby and extracting the ice for other sources of energy.
Yeah, I saw an idea where someone was saying like you would, I think it was Zubrin was saying that you would set up your solar panels and then beam your microwave power down to collectors that are harvesting the water, and you could sort of transfer the energy from one location to another to try to get at that water. So Gareth, Jeff Bezos recently said that anybody who wants to go live on Mars should go spend some time living in Antarctica, specifically the dry valleys in McMurdo. You've been there. What's it like to live there?
It's quite bleak. It's very beautiful, but it's a hard place to live. When we were there, we had to live off the land a little bit. We'd take snowpacks, which would be almost rock solid because of the conditions, and melt those down. But I do think, from an Earth point of view, it's probably the best analog we have to Mars. The issue, of course, is that on Mars you can't breathe and the temperatures are lower, so you have to take that into account. But there are a lot of similar landforms. It just gives us a really good insight. Once again, use that word, what we expect in Mars.
And do you think, though, like for the people who are, the lineup of people who say they want to go and fly to Mars and spend a year there or a lifetime there, do you think that region would prepare them even just a little bit, except they also get to breathe, spend a year there?
No, I think so. I mean, the landscape's very familiar, and kind of some of the harshness as well would be beneficial. And also just getting used to living in a small tent with a group of people is probably a good thing from a social point of view, you know?
Yeah, that sounds good. All right, so then what what is next? What can people expect to see in what you guys are working on?
So on the up to this point for the ice mapping project, we've kind of been concentrating in certain areas in the northern hemisphere of Mars. And we're about to release these results for this broad mapping study. We're in discussions right now with NASA about continuing the work to extend it both in space and complexity. And by space, I mean, include areas in the southern hemisphere and elsewhere in the north that we didn't get to. And in terms of complexity, just basically use some more sophisticated means to try to, tease more information out of these data sets. The other thing that's coming out of this study is sort of a better understanding what the real limitations of these data sets are, and what we probably want to do next as far as new spacecraft and instruments to better solve this problem.
Awesome. And where can people find out more if they want to follow the project and see the results? Where can they see what you're working on?
We have a website set up. It's swim.psi.edu. That's swim.psi.edu.
All right, I'm going to bring that up right now. There we go. So you guys can see what's on the screen right now. That's the site. Excellent.
Yep.
And Red Planet Swim.
Yeah,
Perfect.
right. So we have a Twitter account there as well.
Excellent. All right. Well, Gareth, Than, thank you so much for taking the time to chat with us today. I really appreciate it. I got the right camera back. Yeah. And good luck. And when we actually do set foot on the Red Planet, I will appreciate the detailed maps.
You're welcome. Thanks for having us on.
All right. Thanks. And
Yeah,
thanks,
very
Gareth.
much.
All right. Take care.
Bye-bye.
Bye.
All right. So again, before we move on to the next stage of the show, I just want to remind everybody who is watching, if you want to become a member of the Weekly Space Hangout crew, please do that. Go to wshcrew.space. They will give you access to all of the cool stuff so that you can become an executive producer of the show, just like everybody is. All right, let's move on with the stories. Morgan, Crew Dragon, sad trombone.
Yeah, it was not a good week for SpaceX. I think this was it late last week or was it over the weekend? They were doing a test on the test stand of the Crew Dragon capsule that had successfully visited the ISS earlier this year, came back, splashed down in the ocean, was brought back, and they were planning to use this capsule for the abort test that was supposed to be carried out really any time now in the next month or so. And so they were basically doing the preparations and firing the engines to get it ready to do that test. And something happened. And that's about all we know. About a day after SpaceX and NASA jointly announced that there had been some sort of anomaly at the pad, a leaked video was released on Twitter that seemed to show a very, very serious problem. I think explosion is probably the right term to use. The video is of exceptionally poor quality, and it's really hard to see basically anything. But it's clear that the capsule suffered a really, really bad fault. And we can all speculate about what that might be. But there's no public statements and really no leaks about what the source of that fault was. And it may well be quite some time before we know. I looked back at when one of the previous commercial resupply missions to the ISS had blown up on the pad for SpaceX a couple of years ago now. And it was almost a month before they made really any statement at all, and something like 3 months before they advanced any sort of preliminary idea of what might have happened.
Mm-hmm.
And you imagine that the stakes for this are substantially higher than that because this is going through the process of being rated for human spaceflight. And the capsule did not look ready for human spaceflight when we saw it this weekend. And that's troubling for SpaceX, it's troubling for NASA, and for the whole commercial crew program.
There was some interesting insights from people like Scott Manley, a few other people who know enough about the different kinds of fuels that they were able to get a sense of what kind of fuel from the color, like what they think had happened. And that, from like the orange color fuel that was seen, the clouds of smoke, that they think it was kind of tetrazine. I think what they were able to
so
tell.
The Super Dracos use a pair of fuels, and I'm not going to remember either one of them. But what's notable about them is, unlike many rocket fuels, they're immediately combustible when they're combined. And that's really important when you're talking about having an abort mechanism, because you can't wait for it to successfully light. Right? It's got to work, which is why most abort mechanisms use solid rockets, which are basically indestructible. And once you light them, it happens. There ain't no stopping it.
Yeah.
And this is sort of the liquid fuel equivalent to that. But we can kind of go through a few ideas here, from sort of best case scenario to worst case.
They're not going to tell us, and we're just going to make stuff up. We're just going to speculate wildly.
And like the best case scenario here is that the malfunction was primarily with some sort of pad equipment, something it was connected to for this test that malfunctioned or interacted with the spacecraft in a way that wasn't supposed to happen. Sort of the medium case problem here would be if there was a problem with the spacecraft, but because of human error in, for example, how the fuel was loaded or the way in which the firing sequence was carried out. And then the worst case scenario would be some sort of fundamental design flaw with the Super Draco engine that would basically require them to go back to square one on the engine component of the capsule, which is a substantial piece of it. And if that was the case, we would probably be looking at a delay that could be in excess of a year, could be years of delay if that's the outcome. And they're going to be able to figure this out, because it's always good when these things happen on the pad. Number one, that's why we test. Nobody was hurt, and that's really important. But two, it was connected to tons of diagnostic instrumentation. And so they probably have a pretty good idea already of the general thing that went wrong. But they're going to want to narrow that down before they start making public statements. And NASA is going to want them to be very specific about what went wrong and prove that this is not something that will happen again, either because they've done a redesign or because they can say this was a procedure or this was a manufacturing fault or what have you.
And just to be clear, this was the same spacecraft that had been tested last month, made it to the International Space Station, delivered cargo, returned back to Earth, and then was being follow-up tested. So unfortunately, whatever happened, and again, it could be that it was just a problem on the test stand and the spacecraft itself is perfectly fine, and it could be the thing is chunks of in parts all around. So we have no idea what's left and what's happened.
Yeah, there is sort of a side path of possibilities to all of this, which is that the fault somehow related to the reuse of the spacecraft, either because some component of the engines didn't perform as expected on a second go, or that the fact that it landed in the ocean caused some sort of corrosive damage. And these are worth considering because NASA has already, prior to any of these problems, made it clear that they intend to only use new spacecraft for the commercial crew applications. And SpaceX is going to continue to recover them and potentially use them for other things. But NASA wasn't ever intending to use reused spacecraft. And so if SpaceX can prove that whatever went wrong was principally because of the reuse, that might offer them a shorter path to convincing NASA that
Right.
that this is recoverable. But this is a big deal, and it's a tremendous setback for SpaceX and for Commercial Crew.
Yes. Pamela, do you have any thoughts on this?
I have to admit, I'm kind of really hoping this turns out to be something stupid along the lines like, we learned this composite material we used in this thing that is only used on this thing is corrosive. I'm really hoping we just learn chemistry from this, and you can just replace some simple component with a different material and fix everything. I'm probably wrong, but this is my uninformed hope.
Right. They could just be like, oh, yeah, we forgot to tell you, NASA, but after every Crew Dragon mission, we light them on fire and roast marshmallows. Right? So, since NASA doesn't want to use them anymore, could be that it's, it's fully planned and they're just, I don't know. No,
I don't think it's fully
wrong.
planned, but I think there is the potential that some of the still being tested for space materials just react to seawater different than anticipated.
Yeah.
So there's one knock-on effect to this that's very minor in this grand scheme of things, and that's that for the next Falcon 9 launch, SpaceX has filed plans with the FAA to re-land that booster at sea instead of on the launch pad where they were planning to. And my understanding is that's because the launch pad is still contaminated with this fuel, which is pretty nasty stuff. And they are just going to land out to sea so they don't have to rush the investigation in order to free up the launch pad for that landing attempt. And so we should see that Falcon 9 land at sea and come back to base just fine. So I think it's fair to say that we won't see Commercial Crew launching to the space station this year, at least on SpaceX. Even if this sort of problem Pamela was describing, it's going to put them down the road a few months, and then they have to cancel. They do the abort test, and then sort of prove that it's all together. And we're probably looking into next year. Boeing is sort of slipped to late this year, and so there's still a possibility that they could fly this year. But I think it's probable that will also slip until next year. And NASA, in some ways, was anticipating a little bit of bump in the schedule here because they've already bought additional seats on the Soyuz prior to any of these anomalies happening. And so they were anticipating the need for some schedule slip, but I'm sure that they weren't anticipating that it was going to be as severe as this potentially is.
And one of the worst cases that hasn't come up yet is what is the possibility that they're going to be asked to fly another test mission all the way up to the ISS with whatever their fix is. Because if it's a significant enough fix on the worst end side of things, they might be asked to refly a test. I don't see that, but brainstorming the worst of the worst, that is on the list.
Yeah, I think it will depend heavily on whether because the Crew Dragon shares a lot of parts with normal Dragon, which has quite an excellent record in the last few years of traveling to the space station. And if this is a piece that is turns out to be part of core Dragon as well, that's a substantial problem for them. If this is a piece that's unique to the Crew Dragon, as the Super Draco engines are, for example, then that's a shorter potential fix because it's not contaminating the rest of the product line.
Right. Yeah, and that requirement of having the crew abort capability, you don't need that for the cargo vessels in the way that you need that for the human rated stuff. And so if it is just a problem with the abort system, that's not going to have a big impact on regular cargo Dragon, but still it is a setback, and it's too bad. I mean, I feel like 2 weeks ago we said Elon Musk was on top of the world, SpaceX was absolutely crushing it, and Boeing was really behind the eight ball at this point. And now it looks like, turns out once again, space is difficult, and things are going to take a lot longer and take more tests, and before we get to a place where this is ever routine. Yes.
Space is hard.
Space is hard. Pamela, what do you got for us?
Yes. So one of the things that I really am enjoying is the discovery of Oumuamua last year is leading to people to think about things in a new way. Because while we always had this back of the brain notion that asteroids, comets, objects from other solar systems could be visiting ours, we've all been talking about panspermia for forever, it feels like. The consequences of this, since we hadn't seen it, weren't among our day-to-day questions. And now that we've seen it, there are people going through and doing some really neat thought experiments and research. And two of the things that both came out last week involve what ifs siblings to Oumuamua did cool stuff. And the first piece of research comes to us as really weird and awesome cool stuff often does from Avi Loeb at Harvard. And he got to thinking, okay, so we had one asteroid come through and it didn't hit us, and we're glad because it was pretty big. But the fact that we had one implies there's a really good chance we had others. So he and an undergraduate student went through a whole myriad of different NASA records of asteroid strikes on our planet. And Amir Siraj, the student going through this catalog, was able to turn up a less than a meter across meteor that hit Earth over the South Pacific with a 60 kilometer per second velocity relative to the sun that indicated it was not bound to the sun. It was just a visitor from another solar system. And using the kinds of, we've only seen two, but that's enough to start making predictions, kind of baseline statistics, they were able to figure out that it is reasonable to expect that this is the kind of thing that probably happens such that we've had 450 million interstellar meteors strike the Earth and its atmosphere over the 4.5 billion year history of our planet, which starts to really increase the probability of, if there's life out there, maybe it got carried to us. Now, this isn't to say we didn't originate here, but maybe some of those extreme, crazy extremophiles did, or maybe the crazy extremophiles originated here and we didn't. It's just kind of amazing to think how common these kinds of impacts potentially could be. And now we just need to know that part of the Drake equation for how common is it for life to be. So that was one Oumuamua related result.
I just, before we move on to the other one, I mean, Avi Loeb is willing to look into any crazy idea, and I've talked to him about this, and he's just like, so people are almost like just aren't willing to investigate this stuff, and he loves to just dig into it. And in this case, right, I mean, now after the fact we think about it like, analyze the trails of all the bolides that have been seen and see if any came in at a velocity or at an angle that could have meant that they were interstellar in origin. And what do you know? They found one. And now they found one. Who knows if they're going to find others? And if they do that kind of calculation, it could be that there are chunks of interstellar rocks all over the Earth, that it's just our job to find them and study them. And so now I hope the race is on. And it does sound a bit, and now I'm starting to hear echoes of myself ranting about this in Astronomy Cast, about this idea that life, panspermia, but at a galactic level, that it's moving from star to star. Having a life form be able to live for the millions of years that it would take to cross the interstellar gulfs would be rough. But still, it's one step closer to saying, if we do find life somewhere else, what if it's actually connected to us? That makes the search for life in the universe tougher and weirder. So I love it. What's the other story?
So the other story is also a case of thinking hard about the consequences of objects like Oumuamua. And in this case, it's scientist Suzanne Falser of the Max Planck Institute and Michelle Bannister of Queen's University Belfast. They were at a conference together, and they got to talking over breakfast about planet formation. And one of the things that we already knew is a driver of planet formation is that first clump that forms. Once you get a clump, it's gravitationally able to pull in other stuff. Well, we've already detected in our own solar system one possible asteroid out roughly Jupiter's orbit that's going the wrong way.
Yes.
And is consistent with being captured from another solar system. Well, what if you have asteroids passing from one solar system that's advanced to one that's just forming? And because they're not just a small clump, they're a pretty mighty clump. They go in and they have the potential to form the seeds of planets if they happen to have the right velocity to get caught in that protostar star system. So this is sort of consistent with if you've ever made sugar rock candy. You make a high density concentration of sugar water, and then you seed it with sugar crystals on the stick, and it grows rock candy. Well, that's a chemical process, but you can do the same thing with gravity by seeding a protosolar system with asteroids from somewhere else that then grow up to be the cores of planets. So I just love this notion that at the heart of a world is an alien rock that was born somewhere else. And as you extend out this idea, you can also start to imagine not solar system debris, supernova debris that got strewn off. There's so many different possibilities of the planets here started as debris out there and just came in and started the cycle all over again. And it's just a beautiful thought, and mathematically works out. And we have no way to prove or disprove it, but I'm hoping some science fiction authors run with it.
But again, it's sort of like back to this idea that if indeed there are tens of thousands of objects of interstellar origin passing through the solar system at any time, and some of these can get captured into various orbits around the sun, into complicated, three-body orbits or whatever, that those could then go on to form the seeds, the cores of these other objects. It's a beautiful idea. Someone actually asked me a similar idea on one of my videos about, like, if you just dropped a sphere of iron, like a planet-sized sphere of iron into a nebula, would it start to accrete material around it with its gravity?
And that starts to come down to how dense is the nebula, how long a period of time are you willing to wait? Because the answer is yes, it will accrete it, but will it accrete it at a rate that triggers star formation? And that, given the fullness of time, I don't know if the probability is it will start that process faster than some other shock wave will end up happening.
Right.
It's funny, you get asked all the time by people, like, what happened before the Big Bang? You never get asked, like, what were the planets before they were planets? We tend to think like 4.5 billion years ago and then jump to 13.5 billion years ago without thinking of all the intervening time. And that's funny because the solar system question is at least in principle answerable, unlike the Big Bang one. Like, we know some specific things about what the environment around the sun must have been like when the sun was forming, when the planets were forming, because that's how we have radiometric dates. Is we can sort of calculate back exactly when all of that uranium and must have been created, and it was like 40 million years before the sun started forming. And so, bam, 40 million years ago, before the sun, there was a supernova. And what was that supernova exploding into? Those are questions we can actually interrogate that would tell us a lot about our own history.
Yeah, absolutely fascinating. All right, so a story that I wanted to share with you, and I don't think anyone, unless the people read Universe Today, of course, they probably haven't heard about this, but the Voyager spacecraft and the Pioneer spacecraft are on, speaking of Interstellar, they are our interstellar emissaries. They're on escape trajectories from the sun, and they're heading out. Voyager 1 is at like 60,000 kilometers an hour, and Voyager 2 is like 55 25,000. So both of those are leaving and they're never coming home. And same with the Pioneers. And so a couple of researchers calculated, based on the data release from the Gaia mission, what stars will the spacecraft go near to in the next few million years. And what they found is not many and not close. So the first close call, and I'll sort of show you this it's kind of hard to understand what's going on here. So the first close call, Voyager 1, is going to be getting within 1.07 parsecs, which is about 3 light years from Proxima Centauri, in about 16,000 years. And actually Voyager 2 is going to do the same, and in fact both Pioneer 10 and Pioneer 11 will be doing the same as well at different time frames. And that makes sense, right? Because Proxima Centauri is the closest star.
Centauri.
And so they're going to get closer to Proxima Centauri than we will, because they're heading in the general direction of Proxima Centauri, and Proxima Centauri is moving. But
well, they
then
could have gone in the opposite direction.
They could have gone in the opposite direction. They could have gone farther. Yeah, absolutely. But in this case, they do happen to get a little closer. And then over the course of the next few tens of thousands of years, they make a close call with this star called Gliese 445, which is actually barreling straight towards the sun. And so it's no surprise that it is going to be the one that they get closest to, because this is going to get really close to us as well. But then you have to go a lot farther out. The Pioneer 10 will get within about a light year of a star called HIP 117795, which is in the constellation of Cassiopeia, in about 90,000 years. And that is probably going to be the closest one that they were able to calculate. Now, of course, all the Voyagers, all the Pioneers are already dead. The Voyagers have probably got about 10 to 20 years left before they're dead, before their power runs out. So they won't be able to be there to really see anything. And of course, their camera systems wouldn't be able to provide a closer view. Although, like when Gliese 445 gets within its light year or so of Earth, you could just barely, under perfect skies, be able to see it in the night sky. So there's not going to be that much that you'll be able to see. Now, the good news is, so they were able to calculate out to about 3.5 million years, and then the data is too fuzzy. Maybe the next Gaia data release is going to be able to give more information. The actual golden records that are on the Voyager spacecraft are flipped face in onto the Voyager spacecraft, and it's expected that they will still be playable for the next billion years or so. So they're going to go around the whole Milky Way about 4 times, and still anyone who comes across the Voyagers will be able to play the golden records just as they are right now, and they could probably reconstruct them carefully with whatever advanced alien instruments. So it's sort of a neat idea to think, like on the one hand, just the vast gulfs, the vast distances between us and other star systems. We are looking at somewhere between 40 and 90,000 years that we're going to get within a light year of another star system. And but if you play it out over the billions of years, they will probably come very close.
Well,
to some
that
star
billion
system.
years wasn't picked on accident. When they were building Voyager, they used a statistical model to estimate how long it would take for Voyager to have a 50-50 chance of passing basically within the solar system's distance of another star. And you turn the crank on that calculation and you find out it's about 1 billion years. So shoot off in a random direction, and it would take about 1 billion years to blunder your way as close to a star as, say, Jupiter is, which they imagined was how close it would have to be for some sort of advanced civilization to be able to pick it out. Because if Voyager flew by Jupiter in our solar system, we'd never know. We aren't nearly sensitive enough to that. They imagined in the future that might be possible, but it would take 1 billion years on average for that to happen. And so they built a thing that could survive that long.
Yeah, it's such a great idea. So there you go. Thanks, Voyagers, Pioneers, good luck. Morgan, Marsquakes.
Yeah, we got some great news from the NASA InSight mission this week. You might remember maybe about a month or two ago, we were talking about some struggles that InSight was having with its drill. It was drilling down, kind of hammering down into the surface, and it has smacked into a rock that seems unmovable. And they haven't solved that problem. But fortunately, InSight is not just one experiment, it's really three. And another of those experiments, the seismometer experiment, reported this week that they detected their first Marsquake. And it was a little guy. I think they said if it was on Earth, it'd be something like a magnitude 1 to 2. And it was really so weak, actually, that they weren't able to derive any detail about the Martian internal structure from it, which is sort of the whole point. They weren't really even able to figure out where it was spatially on Mars. They thought it was probably around 100 kilometers away. And they don't even know what it is.
Right,
so they don't know if it was a meteorite striking or some sort of tectonic shift within Mars. So there's a lot of things we don't know. But what we do know is that the instrument's working, and that this quake was picked up on both the low frequency and the high frequency seismometers, unlike three other detections that they are tracking down that were only picked up by one of those two instruments. And so things seem to be working, and that's really great news.
So I'm going to try playing the video here that has the actual sound so people can actually hear it. So
these things are always weird.
Yeah, I don't know if this is going to work so well here. Let me show you what's on the screen right now. So here we go.
So for the beginning, they were just hearing wind, wind sounds. Oh.
Here's the Marsquake. And that's the robotic arm sound.
So these are, it's a really good detection. And one of the things they noticed that was interesting to them was that the sort of shape of the detection was extremely similar to detections made by the Apollo seismometers left in the 1970s. And maybe that suggests that this is more likely to be a meteorite impact than a tectonic shift. But those Apollo instruments were sort of the first generation of off-Earth seismometry. And they're thinking that, it's been about a couple of months now that InSight has been in full-on science mode, and they found one Marsquake. And the mission is supposed to last for about 2 Earth years, 1 Martian year. And so the back of the envelope calculation suggests that they might pick up sort of in the neighborhood of a dozen of these events over the course of the next couple of years. And hopefully some of them will be stronger than the one we heard today, and will actually generate those waves that penetrate down into the interior of Mars. But I imagine that even if all we hear is a bunch of these kinds of detections, that we're going to get a lot of cool science out of them. And they'll help us do things like constrain the rate of meteorite impact on Mars, which is a really, 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 really important number, because that's what helps us connect how cratered an object is with how old it is. And the thing that people don't sort of know is that basically the age of everything in the solar system is based solely on the rates we have for the moon that were derived from these Apollo experiments and the Apollo moon rocks and the Apollo observations. And you never want to base like your whole understanding of the history of the solar system on one collection of observations on one particular world. And so if we can establish these rates elsewhere in the solar system, they'll help us understand things like how old Saturn's rings really are, or what the age of some of the icy moons in the outer solar system are, or how old Pluto is. Things that we're trying to understand, just measuring these plinks on Mars will go a long way to firming up those observations.
So
and
cool.
One of the cool things that I really liked about this that I'd never thought about, and anytime a news report can get me to think about something in a new way. It's cool. The Apollo measurements were consistent with thermal changes in the crust of the moon, where the heating and cooling of the seasons actually causes these long-term, really non-powerful
Cool. I
quakes.
didn't know that.
And so looking at the quake on Mars, no, they don't know what it is, but it is consistent with these thermal changes in the surface of the world.
So cool. I mean, it's so sad that they're having trouble with the mole to get those temperature readings. Like that was going to be really exciting and answer some really big questions. But still, the fact that they're getting some of the seismic activity and potentially detecting the strikes of rocks nearby is fantastic. I can't wait to see more results from InSight.
Well, and InSight's an unusually international mission for a small class mission like this. I think the two seismometers, one was built in Britain and one in France. And I think the drill is maybe from Germany.
It's Germany, yeah.
And NASA is providing the main spacecraft bus and mission operations and integration and all of that. And so it's a really great opportunity to see all these different space programs working together on such a small project.
Yeah. Yeah, and I mean, we've seen that with some of the other ones as well. There's a German rover on the Hayabusa 2 mission, and so I think we're seeing hopefully a lot of this collaboration as people start to get, and everybody needs an arm, so Canada's ready to provide an arm for whoever wants one. All right, we've reached the end of our show. I want to give my co-host a chance to shamelessly self-promote some projects they're working on. Morgan, what do you got?
Also, I actually want to poll the audience. I'll be here next week, and then I'll be gone for several weeks, in part because I'm taking a 2-week vacation to Australia.
Nice.
And we'll be visiting in Sydney and in Melbourne and in Cairns. And other than Cairns, we've planned nothing. So if you happen to live in Australia, or you've been to Australia and you have a clever idea of something cool or something that wouldn't show up in a travel book that we might already have, please tweet it at me at Morgan Renberg, and there's a good chance that we might actually do it.
It's a big place. That's the takeaway that I can give you. It's bigger than you think.
Yes, well, we are airplaning, so that will help
move.
make it smaller.
Pamela.
This weekend, we are going to be celebrating the 365 Days of Astronomy podcast. It's been going on for 10 years.
That's more than 365 days.
Yeah. So we're calling this the 3,650 Podcasts Later celebration. We're going to be doing a 10-hour stream over on Twitch TV/CosmoQuestX. We're inviting all the old podcasters to join us, anyone who's around. Hopefully you got an email from us. We're inviting you all to join us, and we will be there celebrating all day long. Now, of course, we are also saying, hey, if you want to help sponsor the show, I will be recording your ads live. So this is your chance to get me to read anything decent and family friendly on air live as you sponsor an episode of this award-winning podcast. So please be there and join us. And it's going to be all the science all the time this Saturday, all day long, twitch.tv/CosmoQuestX.
Fantastic. And if I sounded knowledgeable about the future paths of the Voyager and Pioneer spacecraft, that's because that's my next video, and we will be dropping that in the next couple of days on my YouTube channel. So if you want to see that in what I just said, but in video form with animations, that'll be your chance. So if you haven't already, subscribe to my YouTube channel. All right, let me get everybody up here on screen with me. On behalf of our special guests, my co-hosts, a big thank you to everybody watching us. Thanks to all the moderators. Thanks to everyone at the WSH crew, of course. We couldn't do the show without you. So, Morgan, you'll be here next week?
I should be.
Yeah. All right. Well, we will see. Some of us will see some of you next week. See you later.
Bye-bye.
And stop.